Please check, check, check. I'm live now, and I can, and the full board is showing now. Have you've joined? Good. And you can still see the board, right? Sharp, sharp, sharp. I've set it well. This is what we'll be using. Very, very clear. Very, very, very clear. Sharp, 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 sharp. Sharp, 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 sharp.
So her name is Success.
Success Academy TV. Success Academy TV. The full board is showing. This is very good. But I'm surprised. I'll normally. You say?
No, now.
What's that?
It's overlapping with the line.
You say?
Your voice is overlapping with the line. Open on Telegram. Come.
I will off my mic when I'm starting to teach.
Okay, sir.
My phone is close to the other phone. That's why I'll work on that. Don't worry, I'm coming. Seventeen people on the live. Where are the others? People should join now. Don't continue this attitude again. Where are the others? After all the stress we have went through now to fix this thing, please join. If someone is teaching, I've seen only 17 people on the group. It's discouraging. Please. In this kind of 10 p.m. nights, do you know how loud I'm shouting? My neighbors are around. They'll say, this person I beg, which kind by 10 p.m. I mean, I'm not a student again, so it must be worth it, please. Let me share today's class to everybody so that, because since people that are paid, people don't want to be even learn. I'm sharing it to all the groups first. Then let's see. But this one now will not be forever for them. If they are not serious, only those that are paid will still enjoy this benefit. You can share the link to your departmental groups or whatever, physics class ongoing, share the link, anybody, let's just find serious students for tonight, because the one thing with class is that the class works with ginger. You understand? Everybody's serious, we work together, we'll push ourselves. But sometimes people that are paid, they are usually the unserious ones. They just have money, but they are not serious. The people that are actually serious, some of them don't even have money to pay. And they're the ones that used to help class to move, to ginger class. Not be all this one. People will just drop money, but they will never attend class. It's bad.
Please start the class now.
Oh yeah, let's start. So first things first, did we watch the video that we did? Please, those on the Telegram, please come to the YouTube, please, because I won't be able to stream the two of them immediately now. Please come to the YouTube, please. I've started the class. I want to go and start the class now.
Well, sir, you said we can talk.
You can talk here, you can talk, but you won't see. Yes, just you can talk if you have question, or if there's anything. If the video becomes blurry, you can tell me on the Telegram. I won't off the mic for the Telegram. You can talk.
That means you should leave the Telegram on now.
Leave it on. Yeah, leave it on. Yes, but join us on YouTube. Okay, so physics. Today, quickly, can you hear my voice well?
Yes, sir.
On the YouTube, you can hear my voice well, right? I'm not using mic, so I can continue.
I can hear your voice from the Telegram, but I'm watching on the YouTube.
I'm saying, but can you lower your Telegram volume and it's fine. Can you hear me from the YouTube? Yes.
Let me check.
Yes. Yes. Are we there? Are we there? Are we there? Okay. Today I want to teach dynamics, physics. I want to look at dynamics in physics today. Want to look at dynamics in physics today? Dynamics in physics today. So please write down, let's look at dynamics. Yes. So please, you should have your writing materials with you. School is resuming next week, Monday. There's no time again. Let's get started. Now, write down, dynamics is defined. Let's define dynamics. In chapter 2 of physics, you have kinematics. This chapter 2, kinematics is talking about the study of motion without reference to the cause of motion. So there's a big difference between dynamics and kinematics. These are two broad aspects of your physics 101. Dynamics and kinematics. So while kinematics deals with the study of motion without reference to the cause of motion, dynamics deals with the study of motion with reference to the cause of motion. Study of motion with reference to the cause of motion. Study of motion with reference to the cause of motion. But kinematics studies motion without any reference to the cause of motion. Studies motion, study of motion without reference to the cause of motion. So class, these are two broad aspects of your physics. Kinematics is talking about studying of motion without reference to the cause of motion, while dynamics is talking about study of motion with reference to the cause of motion. It's a well-known fact that for a body to be moving, there's a reason why the body is moving. But in kinematics, we don't want to know why the body is moving. But in dynamics, we want to know why the body is moving. I'll take kinematics in another class. But today I want to focus on dynamics. Why am I taking dynamics? I'm sure that I've not taught dynamics in any of our classes. So I want to see something fresh. I think I've taught part of kinematics when I thought about how to differentiate, when to integrate in motion. Talking about the equations of motion, linear motion and all that. I want to take a fresh topic. Everybody in this video must learn something new today. But I promise you I'll do a video on kinematics too. So today we're going to look at dynamics. And the first thing we look at, dynamics is the study of motion. Write down. Dynamics is the study of motion with reference to the cause of motion. Now, when looking at dynamics, what is the chief cause of motion? So the key word here is cause of motion. Cause of what? Motion. The chief cause of motion is force. Class. Force is the chief cause why a body is moving. The main reason why a body is moving is due to applied force. Applied force. Please take note. Applied force. Applied force. Applied force is the main reason why a body is moving. So, when looking at dynamics, we're going to be looking at the study of motion with reference to the cause of motion. And then, there are three laws that we must study under dynamics. Newton's laws of motion. So please write down subheading Newton's laws of motion. Newton's law of motion. The Newton's laws of motion helps us to properly understand the cause of motion, why a body is moving. The Newton's laws of motion helps us to properly understand the cause of motion. That is why a body is what? Moving. So let's write down the Newton's laws of motion. Subheading Newton's laws of motion. I hope you're still together. I hope you're still with me. Hope you're still with me. Newton's laws of motion. Newton's laws of motion. Now let's start with the first law. So write down first law. Now even if you know this law, in our university study, we'll be showing you some other key things that you might not have known before. First law of motion. This is very popular, but write it down. Newton's first law of motion. Now Newton's first law of motion states that Newton's first law of motion states that a body will remain at rest if at rest. Newton's first law of motion states that Newton's first law of motion states that a body will remain at rest if at rest, or in uniform motion. A body will remain at rest if at rest, or in uniform motion if in motion, except being distorted by an external force. Except being distorted by an external force. So I'll come again. Newton's first law of motion states that a body will remain at rest if at rest, or in motion, or in uniform motion if in uniform motion, except being distorted by an external force. So what this means is that in Newton's first law of motion, some people when they are stating this law, they only state one part. They just say a body will remain at rest except being distorted by an external force. That's only one part of the Newton's law of motion, first law. There are actually two parts. That's why I stated it clearly that a body will remain at rest. If it's at rest, it will remain at rest. But if the body is in uniform motion, what is uniform motion? A body is said to be in uniform motion when the velocity or the speed of the body does not change in that time interval. That body is said to be in continuous uniform motion. If a body maintains the same speed or velocity, that means speed does not increase, does not reduce, in a particular time interval, that body is said to be in what? Continuous uniform motion. So Newton's first law of motion also makes provision for a body in what? Continuous uniform motion. So first of all, let us explain when a body is at rest. Nothing will move that body. That body will continue to be at rest if at rest. If there is no external force applied to that body will remain at rest. So if you drop this marker, this cleaner, this ball cleaner at this point, and there is no external force to push this ball cleaner will remain here continuously till an external force is applied to push it away. That's the first part. Now the second part, what if the body was not at rest? What if the body is moving with the same speed consistently? That's uniform motion. When the body is moving with the same speed consistently, uniform motion. If the body is moving in uniform motion consistently, and there's no external force to change the continuous motion of that body, the body will continue in that uniform motion, except an external force comes to shift it away from what? The uniform motion. So if a body is moving with a speed of 2 meters per second, if a body is moving with a speed of 2 meters per second, the body will keep moving with that speed of 2 meters per second consistently, except an external force comes to change the speed to maybe 1 meter per second, to either reduce the speed or to increase the speed or to stop the body completely. So that's what Newton's first law of motion is talking about. Now what can we derive from we have 3 Newton's laws of motion. From the 3 Newton's laws of motion, there are mathematical implications. Each Newton's laws of motion has what we call mathematical implications. So what are the mathematical implications? That's where the calculation is. Especially in your exam, for your exam's sake, that's where the calculation is. What are the mathematical implications of that? It means that according to Newton's first law of motion, the applied force is directly proportional to the acceleration of a body. For a body to experience acceleration, there must be an applied force. This is the long and short of Newton's first law of motion. For a body to experience what? Acceleration, there must be an applied force. What is acceleration? Acceleration is two types. There are two types of acceleration. We have what we call the positive acceleration and the negative acceleration. We have what we call the positive acceleration and the negative acceleration. What is positive acceleration? Positive acceleration is the increase in speed or what? Velocity of the body. When the body's speed increases, but the velocity, another name for speed is velocity obviously. When there's an increase in speed or velocity of the body is said to have experienced positive acceleration. When there's a decrease in speed or velocity of the body is said to have experienced what? Negative acceleration. Now, the force applied, why do we have to understand positive and negative acceleration? Because for the first part, a body will remain at rest. When a body is at rest, it is known that the initial velocity u is 0 meter per second. When a body is at rest, the initial velocity u is 0 meter per second. Now, a body will remain at rest if at rest, except an external force is what? Applied to it, right? Now, when an external force is applied to this body that is at rest, the body will now move, right? Once the body moves, it's no longer 0. It means that for a body to move, someone that was having a speed of 0 must have probably increased to a speed greater than 0, maybe 2 meters per second or 3 meters per second. This change in speed from 0 meter per second to 2 meters per second is a positive acceleration. So applied force can cause, what I'm trying to explain to you here is that applied force on a body can cause either positive acceleration or negative acceleration. And negative acceleration is what we know as retardation or deceleration. So I'm explaining to you how applied force can cause positive acceleration. I'll also explain to you how applied force can cause negative acceleration. Let's show you how applied force can cause negative acceleration. Let's look at the second case study. So the first stage says the body will remain at rest if at rest or in uniform motion. Actually, the word is in continuous uniform motion, if in uniform motion, except being disturbed by an external force. How can applied force cause negative acceleration? Follow me carefully. Applied force can cause negative acceleration in the sense that, let us say a body is moving with a consistent speed of 2 meters per second. 2 meters per second. 2 meters per second. Remember that this Newton's first law of motion, the second part says a body will continue moving with that same speed. That is, moving with the same speed means uniform motion. A body moving the same speed. When a body's speed does not change over a long period of time, that body is said to experience uniform motion. So 2 meters per second, except an external force is applied. Let us say an external force is applied, and this body speed now, that force now comes to distort this body speed. Now there are two things that force can do to this body speed. It can either increase it from 2 to 3 meters per second, or slow it down from 2 to 1 meter per second. So if a body is moving with a very fast speed and a bigger body comes to collide with that body and slows down the body, it has reduced the speed from 2 to 1 meter per second. And when the body speed has reduced from 2 to 1 meter per second, that body is said to experience negative acceleration. And this therefore shows us that applied force can cause either positive acceleration or negative acceleration. Please take note. Now, I have understood that this is the mathematical implication. If you are asked in your exam, because your exam is objective, if you are asked that which of the following is the correct mathematical connotation for Newton's first law of motion, which of the following is the correct mathematical connotation for Newton's first law of motion? F is proportional to A. Class, are you aware that the popular formula that everybody knows that force equals to mass and acceleration is derived from Newton's first law of motion? F equals to ma is derived from Newton's first law of motion. Please, those on the Telegram, please give me a signal that you're still with me and your mic is still on. I hope you're still there. Now F is now equal to ma, because if F is proportional to a constant will come in. The constant that comes in is m, the mass. Anytime you have proportionality sign, if F is proportional to a constant will come in to break this sign, so that F equals to ma. So force equals to mass times acceleration. This is the very important formula for Newton's first law of what? Of motion. F equals to ma. Now, let's take down this question, class. Everybody write down this question. I'll give you two questions. Please write down this question. Calculate the force. Calculate the force calculate the force. Calculate the force acting on a body of mass. Calculate the force acting on a body of mass 5 kg. Given that it is moving at a constant velocity of 3 meters per second. Calculate the force acting on a body of mass 5 kg. Given that it is moving at a constant velocity of 3 meters per second. I want us to try this question. You will be writing material. You have that force equals to ma. I want us to try this question. I'll give you 1 minute to write down this question and try it. Try this question. Let's see, class. Try it. Let's see. Make sure you're still with us. Yes, make sure you're still with us. Please, if you're still with us on the YouTube, can you drop a comment to show that we are still together? Please drop a comment. Let's be sure that we're not just teaching ourselves. Drop a comment. Those on the Telegram, drop a comment. Let us know we're still teaching. Please write down this question on the board. Calculate the force acting on a body of mass 5 kg. Given that it is moving. Thank you. Yes. Bello Press said, yes, I'm still here. Well done. Glorious Brick, I'm still here. Thank you. Well done. Well done. Because this is midnight. Imagine me talking to myself alone. And I'm not the one writing exam. Let me know whether I should go and sleep. This is midnight. Okay, yes, sir. Okay, yes, still with me. Yes. Someone said we did. Rejoice said we did. Well done. Thank you. Good. Who else is with us? I'm seeing your comments on YouTube. Drop a comment. Someone said hi. Yes. Chibu King said hi. Virtue Great said yes, sir. Joy Wisdom said I'm still here. Well done. Yes. No time coefficient, sir. I'm still here. Yes, sir. Good evening, Mr. Success. We are still here. Good. Michael said, Michael Obiri say active. Yes. Wonderful said, I'm still here. Well done, class. Well done. Yes, I'm going to solve the question. I'm giving you 1 minute. Think on this question. What is the solution to this question? I'm giving you 1 minute. Think. Someone said 15 Newton. Okay, someone said, what's this person? 15 Newton. Bello Praise said, we know they go anywhere. Good. Bello Praise said, we know they go anywhere. Favor said, I'm here. Good. Mercy said, we are active. Yes. Well done. Someone said, keep it up, sir. Someone said, active. Oh, yes. Well done. At least this is encouraging. Because this is midnight now. Imagine me talking to myself. Everybody don't go sleep. Thank you. Someone said present. Adeyanju just said present. Well done, class. Well done. Someone said 25 meters per second is the answer. They asked to calculate the force. Force cannot be in meter per seconds. Someone said I'm active here. Prince. Yes. Prince said I'm active here, sir. Yes. Emmanuel said I'm active. Yes. Osade said I'm active. Blessings. Omoyeni say I'm active. Yes. This is encouraging. Well done. Yes. Someone said 15 Newton. Someone said size 15 Newton. Go ahead. Let me give you 1 minute. Solve. Get your writing material. Solve. Yes. Iskalina said yes, sir. Well done. Iskalina favor. Yes, sir. Ooh, good. Someone said, okay, Virtue Great said answer is 15 Newton. Rejoice said your sanity is intact, sir. Yes. Present. Adeyanju said present. Yes. Men mount. Amechi said men mount. Yes, that's good. Well done. Please solve that question. Solve the question. Let's see what you have. I'll come and do the correction. 15 Newton. Everybody's saying, sir, the answer is 15 Newton. Okay, interesting. Sir, the answer is 15 Newton. Yes, 15 Newton, size 15 Newton. Okay, let's do the correction and find out. Let us do the correction and find out. Someone said we can hear you from Telegram, sir. Yes. So are we ready for the correction? Someone said time wasn't given, but time isn't given. Okay, I intentionally gave this question to surprise all of you. Watch what's going to happen. With this solution. What the solution, everybody? What the solution? Someone says, sir, I don't understand. Divine Favor said, I don't understand. Yes. Watch. Oh, the first person someone has gotten the answer. Michael Obirisike said 0 Newton. You caught me. Yes. Maxi also says 0 Newton. Yes. Someone says, sir, correction, please. Rejoice said correction, please. Let me go and do the correction. Those that went for 0 Newton, you are correct. Okay, I'm cleaning the question. Those that went for 0 Newton, you are correct. Look up. Let me tell you why the answer is 0 Newton. And these are they'll catch you in the exam. Let me rewrite the question. Follow me carefully. They say calculates the force acting on a body of mass 5 kg. Calculate the force acting on a body of mass 5 kg, given that it is moving at a constant velocity of 3 meters per second. Class, it's not every question they give you parameters that you use to solve. First of all, they say calculate the force. And they gave you mass as 5 kg. they give you velocity at 3 meters per second. For class, for a body to be moving with constant velocity, it means the body is in uniform motion. And a body moving in uniform motion means that there is no applied force, class. Don't forget Newton's first law of motion. The body will remain in a state of rest if at rest, leave that side first, or a state in continuous uniform motion if in motion, except being distorted by an external force. What does that statement mean? It means that as long as the body is in continuous uniform motion, it means that there is no force applied on the body. Because once a force is applied on that body, the bodies will no longer be in uniform motion. What is the definition of uniform motion? Constant velocity. Constant velocity means the velocity does not change. That means the speed of velocity also means speed. The speed of velocity does not change. The speed of velocity does not change. So when the body speed or velocity does not change over time, class, it means that there is no applied force on the body. Because what will make a body to keep moving with the same speed? If there is a force applied on the body cannot have the same speed. So class, anytime you see a question asked to calculate the force acting on the body, class, just look for 0 Newton. Look for what? I'm going to prove it mathematically. I'll prove it mathematically too. I'll prove it to calculation. But I'm proving this first theoretically based on Newton's first law of motion. That's why I told you that you could have known, many of you know Newton's law of motion, but you see, you still feel this question. So someone could have joined us live and saw the topic, Newton's law, let me go, and you just left. No. You watch. What if they give you a question I cannot solve? So as we're saying in class, F equals to 0 Newton. F equals to what? 0 Newton. Let me explain it mathematically now with formula. Let me show you. Class, if F equals to ma, we have m as 5 kg. We don't have a. But I want you to remember that what is the real formula for acceleration? Acceleration is changing velocity all over time. Do you remember? The acceleration is what? Change in velocity per unit time. That's acceleration. So, class, you see on that reason again. So acceleration has to be change in velocity. There must be a change in velocity. That must be the final velocity and minus initial. But class, the question says constant velocity means that there is no change in velocity. So it means that constant velocity means that both the final and the initial are the same. So both v is 3, u is 3, because the body started with 3 meters per second and it continued with 3 meters per second. And it still ends with 3 meters per second. So both u and v are the same, constant. So that is, a is going to be 3 minus 3. Someone was saying, sorry, they didn't give us time. I was looking at the comments. Someone said, they didn't give us time. Class, you don't even need time. Let us even put time as t. But we are sure that both v and u are 3 and 3 because the body is constant velocity. So the final velocity is 3, the initial velocity is also 3. What is 3 minus 3? Is it not 0? Now 0 divided by t, whoever t is, whether you are given or not, 0 divided by anybody is 0. So this already shows that our acceleration is 0 meter per second square. Our acceleration is 0 meter per second square. And what does that mean? It means that if acceleration is 0, our mass is 5. Force is mass times acceleration, 5 times 0, which give what? 5 times 0 is 0 Newton. So I've explained why the answer is 0, both theoretically and mathematically. I hope we all understand. Let me see the comments. Is there anybody that's lost? If you are lost, you can drop a comment in the comment section. I hope we all understand this. Who is lost? Anybody lost? Let me see your comments again before I go to the next question. I want to give you another question. Yeah, someone says, sir, Bello praise. Say, oh, what a tricky question, sir. Yes. Surprising. Yes. Someone says surprise. Someone says sharp. Someone say, wow, I get it now, sir. Yes. Someone said, yeah. Omo Edit said yes. No be lie. Yes. Amadi said no be lie. Danny G said sharp. Yes. Danny G said sharp. Emmanuel said, thank you very much, sir. Yes. Rejoice said, this is brilliant. Yes. David said, I get it now. Right on, sir. Yes. Divine Favor is laughing. I hope you understand. Someone say, well understood. Okay, someone says, sir, the second question, I'm ready. Someone says, keep it up, sir. Someone say, mad. Good, mad though, Abi. On my shoko. Yes. Okay, let's go. Let's take the second question now. Let me get my book, my test. I want to bring some question from the past question. Let me get my book quickly. I'm coming quickly. Yes, I'm back. So write down this question. Write down this question quickly. Let's take another question, class. Are we ready? Are we ready, class? Let's go. Now, let's go now. A car of mass 500 kg. Let's take this question that a car of mass 500 kg. I hope you are still with me. A car of mass 500 kg. 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 Are you there? I wish you two can allow students to talk too. A car of mass 500 kg is acted upon by two opposing forces. A car of mass 500 kg is acted upon by two opposing forces. F1 is 3000 Newton and F2 is 4500 Newton. A car of mass 500 kg is acted upon by two opposing forces, F1 300 Newton and F2 4500. Calculate the acceleration experienced by the body. Calculate the acceleration experienced by the body. Okay, the body is the car, right? By the car. Class, solve this question. I'll give you 1 minute. A car of mass 500 kg is acted upon by two opposing forces. F1 equals 3000 Newton and F2 equals 4500 Newton. Calculate the acceleration. Yes, Amadi Greatness says, size, your passion is still available. Yes, it's available. The passion is available, yes. When school resumes next week, you can get it. The past exam question is still available, yes. A car of mass 500 kg is acted upon by two opposing forces. A car of mass 500 kg is acted upon by two opposing forces. F1 equals 3000 Newton and F2 equals 4500 newtons. Bello Pray says, sir, you go call options. I should give you options. Okay, option A. Let me give you option. Oh. Someone, Success said, I'm saying Success, my name 6. Success, Olu said 3. Option A, 4 meters per second square. Option B, 3.2 meters per second square. Option C, 3.1 meters per second square. Option D, 5 meters per second square. Option E, none. A car of mass 500 kg is acted upon by two opposing forces. F1 equals 3000 Newton and F2 equals to 4500 Newton. Calculate the acceleration experienced by the car. Someone said, are we to solve for positive? Yes. Amechi Decency. Are we to solve for positive and negative acceleration? No. A body cannot experience both positive and negative at the same time. A body cannot experience both positive and negative at the same time. Please, don't write your option in the, just tell me what is your correct option answer. Some people are still writing there, like, is it option A, B, C, D, E? You asked me to give you option. I'm giving you option now. I'm giving you option now, so let's know. A car of mass 500 kg is acted upon by two opposing forces. F1 equals to 3,000 Newton. F2 equals to 4,500 Newton. Calculate the acceleration experienced by the car. Calculate the acceleration experienced by the car. Someone said 3.1 on the Telegram. Someone said 3.1 on the Telegram. Okay. Class, someone said I think it's C. Michael Obiri says it's C. C. E. C. E. Someone said no. Some of you like none of the above. Anytime you don't have idea, just look for none. Either you look for none or all of the above or some of the above. A car of mass 500 kg is acted upon by two opposing forces. F1 equals to 3,000 Newton. Okay, correction time. Let's go to look at the correction.
5 minus 3,000 would be 1,5. So you divide x squared over a.
Good. I like one person saying something here. Lara Barry said acceleration should be in direction of the greater force. Class, I'll use this question to teach you something now. Let's go. Yes. Now, look up. Class, anytime you are told that two forces are acting on a body, we all know that force F equals to mass times acceleration. Now, what must be confusing some students? Look up. Some students, what is confusing you is that you are wondering, F equals to mass times acceleration. Which of this F will I use? This F1, this F2. So, there are two forces acting on the body. Which of the forces will I use? Let me teach you something. Anytime two forces are acting on a body, note that the greater force always overcomes the lesser force. So for two forces to be acting on a body, especially when they are acting in opposite direction. Now, look at this force, F1. And look at this force, F2. This is 4,500 Newton. This 3,000 Newton. Since they act in opposite direction, it means that this one is trying to pull it like this. This one is trying to pull it like this to this way. While this guy is trying to pull it to this side. Now this guy is carrying 3,000 Newton. This guy is carrying 4,500 Newton. Where do you think this body will go? Left or right? This body will clearly go to the right. Do you know why? Because this force is bigger than this force. What will happen is this. Even if this force was the one that won the battle, not all of the 4,500 Newton is going to lose some. Because class, after this 4,500 Newton, is going to spend 3,000 of his 4,500 to overcome this 3,000. So we'll have to look for the net force. You're going to calculate the net force. When you say F equals to MA, this F actually means net force. So most people just know that F equals to M, but they don't understand that that force is actually the net force or the resultant force. So if you say net force, is what you're going to look out for. So anytime they give you two forces, don't say, I'm going to use the bigger one, I'm going to use the smaller one. No. You're going to use two of them. The bigger force should overcome the smaller force. So you're going to say the net force. Watch, the net force is going to be the bigger force, F2 minus F1. The net force is the bigger force minus the smaller force. So that the net force will be, what's the bigger force? 4,005. What's the smaller force? 3,000. So that 4,500 minus 3,000 will give us what? 1,500 Newton. This is the net force. So we're now going to say that the net force, which is 1,500 Newton, is now going to be equal to, what's the mass? 500 kg. And what's the acceleration? That's what we are looking for. So even if the question asks us to find acceleration, we have to first resolve these two forces. Anytime they give you a question under question and they give you more than one force, 2, 3 forces, you must resolve those forces first before you can find the acceleration. Because in this formula, there's only one force. So you must find a way to resolve the dynamic between these two forces. That's why this topic is called dynamics. It's called what? Dynamics. So let's do dynamics today. So you must resolve these two forces to get the net force. It's only one force you must put in this formula, which is MA. The one force in this formula is the net force after resolving the two forces. So this 3,000 Newton and 4,500 Newton, they are dragging this car. You must find the net force on this car after they are finished dragging each other. The net force, the surviving force, net force is not like the surviving force. The surviving force between 4,500 and 3,000 is only 1,005. Is that surviving force, which is the net force, that will be equal to mass 500 times A. You're now going to make A squared of the formula. If 1,500 equals to 500 times A, if you make A squared of the formula, your A will clearly be equal to 1,500 divided by 500, right? Because you're going to divide both sides by 500. Divide both sides by 500. So 500 cancels 500. So A is 1,500 divided by 500, which is 3 meters per second squared. Now, one more trap I set for you, class. I intentionally did not put 3 meters per second squared. I intentionally did not put 3 meters per second. Many of you fell for the trap. You went for 3.1. Class, 3.1 is not the same thing as 3. The correct answer is none. The correct answer is what? None. If this none was not on the board, then you go for the closest answer to 3. But it's none. Class, 3 and 3.1 are not the same thing. Especially when it comes to science field, where a 0 millimeter can be a big difference, a big something. That 0.1 in physics, in aerospace, can be different between a plane crashing into something or not. Just the space between a plane and an obstacle or something, or even in the. Do you understand? So this 0.1 matter. The answer is none of the above. None of the what? Above. It's now time to give you another question. It's time to give you another question. Let's take this question down. But before I give you another question, let me just go check. I hope you understand this very well. Is anybody lost? Are you still following? Yes, good. Is anybody lost? I hope you follow. I hope we understand. Let's see your comments again. I hope we're understanding. Yes. Sam Maxi said, good teaching, sir. Good teaching, sir. Someone says, sir, can they give 3 forces? Yes, they can give 3 forces. You're going to resolve them. I will give you a question very soon that I will do with 3 forces. Yes. Gloria said, well understood. Yes. Someone said, quite extravagant. Okay. I know Sabi English like that. Oh, yes, sir. Someone said, yes, sir. Yeah. Emmanuel said, yes, sir. Okay. So, Rejoice said, next question, please. Yes. Rejoice said, next question, please. Good. Okay, now let's take another question. Let's take another question. Class. A car of mass 500 kg is acted upon by 2 complementary forces. A car of mass 500 kg is acted upon by what? 2 complementary forces. This same question, but instead of 2 opposing forces, 2 complementary forces. Find the acceleration experienced by the car. Class, solve. A car of mass 500 kg is acted upon by 2 complementary forces. A car of mass 500 kg is acted upon by 2 complementary forces. F1 equals to 3,000 Newton and F2 equals to 4,500 Newton. Calculate the acceleration experienced by the body. Go ahead. Let's see. Anybody that solved, you can drop your answer in the comments. First answer. Let me see the first comment. Good. More people are joining us. 62 students are on this live class. Someone said eye opener. Yes. Very bad man said eye opener. Is it very bad man or very dark man? Which one? This one say options, please. Emmanuel said options, please. Options, please. Emmanuel said options. Let me give options. Option A, 9 meters per second square. Option B, 6 meters per second square. Option C, 3 meters per second square. Option D, Option D, 15 meters per second square. Option E, none. Option E, none. So let's see your comments. Someone said option, who is this? Lera Barry said option D. Quickest said option F. 15. Chemo Scott said 15. Well done, well done, well done. It shows everybody still active in the class. Well done. Someone says clearly none. CMAV says clearly none. Virtual Great said it's D. Messi Bamidele said it's D. Someone said it's clearly none.
The answer is no.
So, okay. Someone also said none on the Telegram channel. It's good. I'm happy to see that people are still active on the Telegram channel. Well done, well done, well done. Yes, someone said it's still none. D, none. So it's between D and none. D and none. D and none. D, since the two forces are complementary. Emmanuel said, since the two forces are complementary, yes. I like educational convos like this. Good, 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 good. I like educational convos like this. Good. Drop more of your comments. They're interesting. Good. 62 people on the live channel now. Well done, well done, well done. It's D. It's D. Everybody's saying it's D. Okay, let's look at the correction. Class, let's do the correction together. A car of mass 500 kg is acted upon by two complementary forces. F1 is 3000 Newton and F2 is 4500 Newton. Calculate the acceleration experienced by the car. Class, the key word here is complementary. Class, for complementary forces mean that the two forces are acting with the same interest. So they are not fighting each other. The former question was opposing, they were fighting each other. But now that they are complementary, it means that the two forces are acting in the same direction. So F1 is 3000 Newton, F2 is 4500 Newton. Since the two forces are complementary, class, the net force, you still have to resolve them. Because they are working together, we are going to add them together. 3000 plus 4500. Because the two forces are working together, that will give us 7500 Newton. So the net force that helps to push this body is 7500 Newton. Because this time around, this 3000 is not attacking this 4500. They say let us work together. So total force summed up together is 7500 Newton. So now the net force 7500 Newton. We'll now use it to find our acceleration. 7500 equals to mass is 500 kg times acceleration. Now I'm going to divide both sides by 500. Divide both sides by what? So that A is 7500 divided by 500. I think that will give us 15. So 75 divided by 5 is what? Acceleration is what? 15 meter per second square. 15, which is D. Option D. Option D. Option D. Is that clear? Is that clear? Let's see your comment. Is it clear? Is it clear? Is that clear? Let's take another question quickly. Let's take another question. We'll take another question. Okay, someone says, sir, please take the mic closer. Take the mic closer. The mic is closer. I don't know what to do again. Please. Some people, is there anybody that cannot hear me well? Someone said, are we doing wave this semester? No, wave is next semester. Wave is Phys 115 next semester. And it's not everybody that will do wave. It's not everybody that will do wave next semester. It's not all departments that will do wave next semester. They said, please take the mic closer so we can hear you well, sir. Okay, I'm not actually using a mic. I'm using... Okay, someone said, I can hear you clearly. Oh. Sir, it's clear. So that person must be network because it's very clear. I'm even shouting in the night, safe. Yeah, we can hear you clearly. Yes. Someone said, we can hear you clearly. Yes. Okay, says, yes, you sound great now. We can hear you clearly. Clear. We can hear you clearly. Yes, Amechi said we have to add the forces, correct. We can hear you perfectly. Yes. Let's take another question. Let's take another question, class. Another question. Another question. A car of mass 500 kg. A car of mass 500 kg moving with a forward acceleration A car of mass 500 kg. I don't know. Should I be dictating the question so it can be faster? Guys, what do you think? Should I be dictating the question? And I can be closer to the mic too. A car of mass 500 kg moving with a forward acceleration of 6 meters per second square. A car of mass 500 kg. Okay, someone said yes. So I should dictate the questions. Oh, so Christian said we should write it. Someone said we should write, someone said we should dictate. Okay, a car of mass 500 kg moving with a forward acceleration. A car of mass 500 kg moving with a forward acceleration. A car of mass 500 kg moving with a forward acceleration of 6 meters per second square is acted upon by a constant resistive force. Is acted upon by a constant resistive force of 800 Newton. Is acted upon by a constant resistive force of 800 Newton. Of 800 Newton. Calculates the force. Calculate the force exerted from the engine. Calculate the force exerted from the engine to maintain this forward acceleration. Calculate the force exerted from the engine to maintain this forward acceleration. Calculate the force exerted from the engine to maintain this forward acceleration. Class, solve this question. Just like we have been doing. Solve this question in 1 minute. Let's see. Please let me fill. I want to go and fill my marker ink. Let me get ink. So solve the question why I think the ink is getting blurry so you can see the board well. So solve the question. Calculate the force exerted on the engine to maintain this forward acceleration. Who has gotten the answer?
So I got 2,200.
Someone said 2,200. Any other answer? More answers, please. More answers. Okay. We have 2,200. 2,200. I'm seeing a lot of 2,200s. Quicker said 2,200. More answers. Drop your comment. Let's see. 3,000 minus 800. 2,200. Someone said options, please. Okay, let's give options. Should we give options? Okay, let's give options. Option A. $2,200 Newton. Option B. 3,500 Newton. Option C. 3,800 Newton. Option D. 800 Newton. Option E, none. So I'll give you the options now. What's the answer? So people are saying A. People are saying A, 2,200, 2,200. People are saying A, 2,200. Someone saying C. Michael said C. Michael Obirisike said C. Yes, yes. Next Gen said C. A. Rejoice said A. Quickest said A. Chibike said A. Next Gen A. Virtues A. Lord Girl Forever C. Ebuka Nwansi C. Divine Favor Emmanuel A. Correction time, right? Very Bad Man A. Koreb A. Lera Barry A. This already can show me the percentage of students that will pass and people that will not pass. Class, let's do it together. Are we ready? Are we ready? Everybody has solved, Abby? Okay, who is this? Aga Philip. Aga Philip, 3,800. C. Osadebam. Goodness. C. Okay, Osadeba has removed that message. You're not sure if you are correct. You're not sure of your answer. Chimwe Scott, CEC. Okay, correction time, class. Correction time. Let's go. A car of mass 500 kg moving with a forward acceleration of 6 meters per second square is acted upon by a constant resistive force of 800 Newton. Now, note the word resistive force. What does resistive force mean? Opposing force. Resist means to oppose, right? It's not complementary. Take note. And the resistive force is 800 Newton. What's that? They give us, so it's a car of mass. So the mass is 500 kg. So our mass is 500 kg. It's moving with the forward acceleration. So acceleration is forward 6 meters per second square. But a constant resistive force of, so a resistive force of 800 Newton. So let's call it FR. FR, 800 Newton, because the force is resistive. Now, they ask us to calculate the force exerted from the engine to maintain the forward acceleration. So the body still moves forward, but they are telling us that there was a resistive force so that did not allow the body to move forward. So therefore, this 800 Newton they gave us is the force that was overcome. Apart from those that are very good in physics. If you were not good in physics, and normally you are not in this class, I'm sure you must have been wondering, but they're giving us force now, because to some students, force is force. Do you understand? They say, but they're giving us force of 800 Newton now, why are they asking us to calculate force again? That's why if you notice in my option, I still put 800 Newton. And this is how a lecturer will behave too in the exam. They will put the 800 so that some students that will feel it's like the right trick up. If there's already force now, it's like they made a mistake. They will not choose this 800 and you are wrong. This 800, yes, it's there, and it's still asks you to find force again, because now you understand that in dynamics, there can be more than one or two forces acting on the body at the same time. So take note. So a constant resistive force is acting on the body. But class, for this body to still move forward, it means that there was a bigger force that overcome the resistive force for the body to move forward. So let us paint the picture of what is happening here. This is the body, 500 kg mass, right? Now, there's a force that wants to move the body this way, but there's another opposing force that's taking the body like this. This is the resistive force of 800 Newton. This is the resistive force of 800 Newton. This force also takes the body away to this side. But there's a bigger force that overcame this force. That was why there was a forward acceleration. They said there was a forward acceleration. There was a forward acceleration, right? So it means that there was a bigger force that overcame this 800. We don't know the force. We don't know the force. So we're going to say, class, follow carefully. We're going to say that the bigger force, class, for this body to move, the net force on this body, what's the net force on this body? The net force is this bigger force. Let's call this bigger force FB. That's the bigger force. Minus the resistive force. must be equal to mass times acceleration, because net force is mass times. So the bigger force minus the resistive force equals to mass times acceleration. Now, what is the bigger force? We don't know. What's the resistive force? 800. What's the mass? 500 kg. What's the acceleration? 6. This bigger force is what they're asking us to find. So bigger force FB minus 800 equals to 500 times 6, 3,000. Now this bigger force is not going to be equal to 3,000 is already on this side, right? When minus 800 moves to this side, it becomes plus. So that 3,000 plus 800 gives us 3,800 Newton. Class, this is the answer, which is what? I think it was C, right? The options I gave. 3,800 Newton. 3,800 Newton. This is very good. Class, well done. We even have more students that have joined. This is 64 people live now. So it's not, it has not reduced. Well done. This is very good. This is very good. This is very good. If you keep this up, this week you see that how much you can cover in this week, even before school resumes. This is good. This is good. This is good. This is good. I hope we are still in the class. Let us drop our comments. I hope we understand this so we can go to another question. Do you understand this? Let's go to so we can go to another question. Yes. Drop your comments. Drop your comments. If you are lost anywhere, let us know. If you are lost anywhere, let us know. Yes, Virtue Great say thanks, sir. Thanks, sir. Yes. I have one more question before I go to the second law of motion. Remember that all these questions are still under just first law. Just first law. One more question before we go to second law of motion. Are we ready? Are we ready for the next question? Okay, let's take the question. Someone says, sir, go over the solution again. Achiki said, sir, go over the solution again. Koreb says, it be like physics go easy. Because the way we are teaching it, Abi, why did we end up adding the both forces? If it is a resistive force, then you need to subtract. No, you don't understand. We subtracted, yes. If not, we did not add up the both forces. Oh, except the person is asking for the former question. Good. We are 69 students on the live now. 69. Numbers are increasing. Well done. This is good. Well done, class. Even by to 11 in the night. This is very good. Well done, class. You guys are doing well. Well done. Now, someone said we should go over the solution again. Let's go over the solution one more time before I give you the next question. Next question will also shock you. So stay tuned. Let me go over the solution again for those that are lost. So a car of mass. Please follow carefully. A car of mass 500 kg, moving with a forward acceleration of 6 meters per second square, is acted upon by a constant resistive force of 800 Newton. Calculate the force exerted from the engine to maintain this forward acceleration. Calculate the force exerted from the engine to maintain this forward acceleration. Now, so this is the mass, 500 kg. Forward acceleration of 6 meters per second. Forward acceleration means that the body actually moves in the positive direction. Now there was a resisting force that did not want the body to move forward. That resisting force is 800 Newton. They are now asking us to calculate the force that was able to overcome this big force so that the body can still move. But for the body to have moved, it means that there was a bigger force that overcame this 800, so that the body now moved. So if you look at the diagram here, this is the resistive force, this is the 800. This 800 does not want the body to move, so it's going like this, right? But the body, this force, is pushing the body in the forward direction like this. This is the force they're asking us to find. If we are to resolve this, the net force on this body is the bigger force minus the lesser force. Remember I told you, there's always the bigger force will overcome the lesser force. That will be the net force. So we say let's F be bigger force minus the resistive force equals to mass times acceleration. So that's what they're asking us for. What's the bigger force that was exerted to maintain the forward acceleration? What was the bigger force? That's what they're asking us to find. So the bigger force we don't know. But minus the 800, which is the resisting force. Remember that the bigger force is always going to minus the smaller force. Then to be equal to the net force, which is mass times acceleration. So the bigger force minus 800, which is the resistive force, and the smaller force, equals to 500 times 6. Mass is 500, acceleration is 6. So FB minus 800 equals 500 times 6 is 3,000. Bring minus 800 to this side becomes plus 800. So 3,000 plus 800 becomes 3,800 Newton. This is the force that was applied for this body to maintain the forward acceleration. Let's take the next question. Let's take the next option. Then we'll go to second law of motion. Let us take the next question. Then we'll go to second law of motion. So you can see that in the popular Newton's law of motion that everybody thinks they know, they could still bring challenging questions. Remember the question we gave that time that the answer was 0 Newton. They can still bring challenging questions. Let's take this question. A body of mass 2 kg is acted upon by 2 forces acting at 90 degrees to each other. F1 3 Newton and F2 4 Newton. Calculate the acceleration experienced by the body. A body of mass 2 kg is acted upon by 2 forces at 90 degrees to each other. F1 3 Newton, F2 4 Newton. Calculate the acceleration experienced by the body. Options. I know someone will ask for options. Let me give you options at once. Option A. Calculate the acceleration experienced by the body. 1.5 meter per second squared. Option B. (2 meter per second squared). Option C. (2.5 meter per second squared). Option D. 3.5 meter per second squared. Option E. 0.5 meter per second squared. All right, class, solve this. I want to see the first answer. If you are following us on this live, make sure you don't leave your colleagues. If your colleagues can stay awake and be learning till now, then you should have no reason why you should leave the class. Your colleagues are, see, this is past 11, and you go and sleep. People are learning, and you pay school fees together. Then you're not ready. So it's good, well done. But I like the engagement. People are still in the class. It means that you have muted all those, your TikTok, your this, and you are serious with the class. That's very good. So someone has already dropped, I think I saw a comment now. Please drop your answers again. Let me see. Drop your answers again. Let me see. Anybody that is done, drop your answer. Drop your answer again. Let me see. Blessing Omoyeni said 2.5. Lebari said option C. Messi Bamidele said option C. Who else? I got C. Michael Blessing Omoyeni said C. Nelson said, "Sir, my network got bad at the 4th question. I didn't follow. Please, can you come again on that?" We can't come again for just you now. What will happen is that this live is being recorded now. It will play it on our YouTube channel. You can go and rewatch. Are we together? Imagine stopping the whole thing just for you. People are awake in the night by this time. Then we'll now go back just for you. Bethel Weacock said A. So Nelson Abraham, yes. So don't worry, you can still go and rewatch. Once this live is ended now, or the video will be automatically uploaded to my channel, so you can go and rewatch. Sodebe said D. Divine Favor said D. Those that are saying D means that you added the both forces, right? Favor Godwin said D. Very Bad Man said C. Glory said D. Glory Bob Manuel said D. Blessing said D. Maxi said, thank you, sir. I thought you would delete it. The Lord Girl Forever said D, sir. E. Next Gen said D. Next Gen said D. Lord Girl Forever said, yes, we added the both forces. She's Achik, he said D. Are you ready for correction now? Well, let's do the correction together quickly. So a body of mass, so our mass is 2 kg. It's acted upon by two forces acting at right angle to each other. 90 degree means right angle. It means what? Right angle. Please take note. Two forces acting at right angle to each other. What are the two forces? 3 Newton and 4 Newton. Class, when two forces are acting at right angle to each other, they are neither complementary nor opposing. So don't minus or don't add. Don't forget, if they are opposing each other, you subtract, right? If they are complementing each other, you add, right? But if they are at right angle to each other, 90 degree means right angle. At right angle means they are perpendicular to each other. 3 Newton and 4 Newton. This is right angle, this is 90 degree, this is 90 degree. The net force or the resultant force is this line, this diagonal line, the hypotenuse of the right angle triangle. So this is the net force. We need to find this net force. And we must remember Pythagoras theorem. That the square of the sum of the square of the adjacent and the what? Adjacent and the opposite. The sum of the square of the adjacent and the opposite is equal to what? Is equal to the square of the hypotenuse. The square of the hypotenuse is equal to the sum of the square of the adjacent and the. So F, what basically means that Pythagoras theorem is one that says that F net square equals to 3 square plus 4 square. Everybody should have known how to do this now from Pythagoras theorem. If two forces are acting at right angle to each other, the reasonable net force is the resultant. This is how you solve questions like this. So to find the resultant, you're going to take these two forces and square them. 3 square plus 4 square. So F square, the net force we're looking for square, equals 3 square plus 4 square. So F, if we find the square root of both sides, find the square root of both. Why are we finding the square root of both sides? So that square root can cancel square, and our net force equals to square roots. 3 square is what? 9. 4 square is what? 16. So what is 9 plus 16? 25. And what's square root of 25? 5 Newton. The square root of 25 is 5 Newton. Now, they didn't ask us to find force, so they said you find the acceleration. But we all understand why we have to get the net force first, right? Now that you have the net force, you can easily go and get the acceleration now, right? Because net force is equals to mass times acceleration, and our net force is 5 Newton. Our mass is 2 kg. We can now find our acceleration. Divide both sides by 2. So the acceleration is 5 divided by 2. Will give us 2.5 meter per second square. So acceleration is 2.5 meter per second square, which is what? C. C. I hope that is clear. 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 C. Good. Divine favor said C. Yes. Yes. Good. Good. Now it's time to go to Newton's second law of motion. Newton's second law of motion. Look at all what we have done. Just first law. You can see? Yes. Newton's second law of motion. Let's go. Quickly, quickly, quickly. Quickly, quickly, quickly. Newton's second law of motion states that. Are we ready? Newton's second law of motion. Let's go. Class, from the first law of motion, it's something I forgot to tell you, although I think you should know that. The first law of motion in the exam, it could be asked, also called law of inertia. The first law of motion is also called the law of inertia. Please take notes. I forgot to tell you that when we stated the law. Newton's first law of motion is also known as the law of inertia. Law of inertia. Newton's first law of motion, also known as law of what? Inertia. And what is inertia? What is inertia? So the first law of motion is called law of inertia. Inertia is the resistance of a body It's resistance a body offers to what? To a change in the motion of it by an applied force. Resistance a body offers is the resistance a body offers to an applied force to stop a change of motion or to stop a change in motion of the body. To stop a change in motion of the body. To stop a change in motion of the body. The resistance a body offers to what? To an applied force. To stop a change in motion of the body. Class, before you can change the motion of anybody, that body, no matter how small, offers a bit of resistance. The resistance that that body offers or puts up, because offer is looking almost like a gift. Resistance a body puts up, you put up a resistance. No, I don't want to move. I don't want to move from here. That thing that stops the body, that doesn't want that body to move, even when an applied force is acting on the body, that thing is called the inertia of the body. And the inertia of the body is dependent on the mass class. The inertia of the body depends on the what? Mass of the body. Class, a body with mass of 50 kg and a body of mass of 500 kg. It is clear that this body will have more inertia than this body. Because mass is what else a body puts up the resistance. Class, a body of mass 500 kg will be harder to lift than a body of 50 kg. Because a body of 500 kg has a higher inertia than a body of what? 50 kg. Even in the mass, it's clear. Even in normal common sense. If they say carry a 50 kg object and carry a 500 kg object, which one will be harder to carry? It's 500. So the harder it is to lift a body, the harder it is to move a body from its current position, the higher the inertia of the body. A body that is harder to move from a particular position means that that body has a very high inertia. While a body that is very easy to move from a position means the body has a low inertia. Yes. So I just stopped to say this. Let's now go to second law of motion, the law of momentum. So you can see, I think from the first law you should have learned now that the law of things that can pop up, that you might think, oh, I didn't know this law of motion. Thank God you stayed. See that there are a lot of things that can still come up that can still make you say, okay, thank God I stayed. This question, I now see it this way, I now understand it this way. Law of momentum. Law of momentum. So the second law of motion, Newton's second law of motion is called the law of momentum. Newton's second law of motion. Newton's second law of motion is called the law of what? Momentum. And it states, Newton's second law of motion is called the law of momentum, and it states that the rate of change of momentum second law of motion states that the rate of change of momentum is proportional to the force applied. And the momentum shifts to the direction of the applied force. States that the rate of change of momentum is proportional. I hope we are still there. states that the rate of change of momentum is proportional to the force applied, and the momentum shifts in the direction of the applied force. Please, everybody drop a comment just to make sure that we're still active. Drop a comment quickly. You know, this on live class and this is already night. We must push ourselves. Someone is asking a question. Aga Philip, sir, if the force applied to a body wasn't enough to shift the inertia, would the body move? No, the body will not move. Yes. That's why the force applied must be greater than the inertia of the body. Let us say you apply a force of 1 Newton on a body of 10 million kg. It will not move now. 1 Newton cannot overcome 10 million kg. It's not possible. Yes. Everybody, please drop a comment. Active. Drop a comment. Yes. Drop a comment, please. Everybody. Yes. You know, we have to push each other, ginger each other. Everybody drop a comment on the YouTube. Drop a comment. Yes, active. Michael said active. Yes, well done, class. Barry said active. Yes, well done. Yes, well done. Yeah, Blessing said active. Yes, it means we are still together. So I can go and continue. Yes. So this is the second law of motion. It's called the law of momentum. Yes, Quicker said active. Well done. Yeah, well done, everybody. Well done. Yes, active. Yes. Adizwa Clinton said, sir. Yes. Rita Martins, active. Osam Morgrace, yes, active. Yes, good. Okay, let's go and continue. Okay, someone said option C, sir, 2.5. The person's network just came back. Yes, active, good. Okay, let's go and continue. Well done, class. Yes, someone said, next gen said, can I say that the force applied? Yes, you can say that, yes. Sir, please, when are we finishing? Very soon, we'll finish very soon. Maxi said, great teaching, thank you. Yes, Correct said, active till 2. Good. Don't worry, we'll soon, let's quickly take the calculation under second law. We'll stop at second law for today, and then we'll continue tomorrow, since we have now seen a method that works well for us. Are we together? Good luck said active, sharp. I'm active, sir. Yeah, praise said active. Divine favor said active but feeling sleepy, sharp. I like your honesty, but good. Still push. Yes. Let's finish second law and take questions and go and rest. Yes. Okay, let's go. Now, mathematically, just like we explained the first law, the second law also has mathematical implication. The second law also has mathematical implication, just like we explained the first law. Now, the rate of change of momentum. What is momentum, first of all? Before we talk about the rate of change. Momentum is mass times velocity, don't forget. The formula for momentum is mass times velocity. So what is change in momentum? Well, the symbol for momentum is P. In physics, we use P to represent momentum. But there are two types of momentum. We have initial and final momentum. We have initial momentum, Pi, let's call it Pi, initial. Pi is mass times initial velocity u. And final momentum, Pf, is mass times final velocity v. So the change in momentum of a body is final momentum minus initial momentum. And what is final momentum? Mass times final velocity. What is initial momentum? Mass times initial velocity. You see that there's m and m here, so we can bring out m, factorize m out. Factorize m out, you're going to have v minus u. So we have brought m outside the brackets. This is change in what? Change in momentum. Now, but it states that the rate of change in momentum, so I've explained change in momentum now, right? Rate means time comes in. So the rate of change of momentum means the rates of change in momentum. Momentum is P, don't forget. Is change in momentum all over time. Change in momentum all over what? Time. Change in momentum all over what? Time. Anytime you hear rate means time. It's proportional to the applied force. So the force applied on a body, let's cut the long story short, the force applied on the body is proportional to the rate of change of momentum. What's the rate of change of momentum? M into bracket V minus U all over T. Proportional to into bracket M into bracket V minus U all over T. The rate of change is proportional to the applied force. And the constant that comes in there is 1. So that F is now equals to M into bracket V minus U all over T. F is now equal to M into bracket V minus U all over T. I'll give 2 assignments and continue from here tomorrow. I'll give 2 assignments on this second law, and tomorrow night we are doing physics again. We're doing physics again. Yes, who wants us to continue tomorrow night? Let me see your comment before we go. I'll give you 2 assignments. You want us, sir? You want us to have the class tomorrow? Continue tomorrow. Let me see your comment. So we'll give you assignments, give you 2 assignments. Yes, sir, we like this YouTube. We want it to continue like this. Yes. Drop a comment, then we'll give you an assignment so you can go and rest for tonight. Yes, good. I'm active tomorrow. Good. Yes. Correct says, sure, sir. Someone said, good luck. Said, yes, please. Good. I like the comment. I like the positivity. Yes. Mike said, okay, sir. Quicker said, yes, sir. Yes, I like the positive comment. Good. Blessing said, yes, sir. Yes. Next gen said, yes, sir. Yes. Bad man said, Nelson said, yes, I'm game for tomorrow. Yes, there will be a replay available. Someone said replay available. Yes. Who post this video on our YouTube? Yes. Rita said, let's continue tomorrow. Yes. Let's give an assignment quickly. Please don't leave without taking the assignment, so that tomorrow you will not come and be lost. Take the assignment down quickly. Take the assignment down. Yes, I'm available tomorrow. Yes, I love this. That's Chinwa said I'm available tomorrow. Good luck. Say at least we enjoy today's class and we'll continue tomorrow. This is one of the classes we've not had any single complaint. So far. Good. Take the assignment down. A body of mass 6 kg. A body of mass 6 kg. Moving with a speed of 20 meters per second. A body of mass 6 kg. Moving with a speed of 20 meters per second. A body of mass 6 kg. Assignments. A body of mass 6 kg. Moving with a speed of 20 meters per second. Is suddenly hit by another body. In the same direction. A body of mass 6 kg. Moving with a speed of 20 meters per second. Is suddenly hit by another body moving in the same direction. Thereby changing the speed of the former body to 50 meters per second. Please write down. Thereby changing the speed of the former body to 50 meters per second. A body of mass 6 kg moving with a speed of 20 meters per second is suddenly hit by another body moving in the same direction. Is suddenly hit by another body moving in the same direction. Thereby changing the speed of the former body to 50 meters per second. Thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? What is the impulse received by the first body? What is the impulse received by the first body? What is the impulse received by the first body? What is the impulse received by the first body? What is the impulse received by the first body? Very important. Yes. What is the impulse received by the first body? What's the impulse received by the first body? Another question. One more question I will go. Are you ready? One more question I will go. A particle of mass, please permit me to dictate this one. I want to dictate this one. A particle of mass 0.4 kg. A particle of mass, please make sure you're writing down. A particle of mass, 0.4 kg, is subjected to two forces. Is subjected to two forces. A particle of mass, 0.4 kg, is subjected to two forces. A particle of mass, 0.4 kg, is subjected to two forces. In Newton, it's related to two forces in Newton. F1 equals 2I minus 4J. F1 equals 2I minus 4J. And F2 equals minus 2.6I plus 5J. If the particle starts from rest, at the origin, find its position and velocity at t equals 1.6 seconds. Find its position and velocity. Find its position and velocity. Find its position and velocity at t equals 1.6 seconds. Find its position and velocity at t equals 1.6 seconds. Class, before you go, please, if you've not subscribed to our channel, hit the subscribe button before you go. Very important. So that when we come live, if you come live for any of our classes, you'll be notified. All my subscribers will easily be notified anytime I go live. If you've not subscribed to our channel, hit the subscribe button before you go. Tomorrow by 9 p.m. Let's meet by 9 p.m. tomorrow. I hope you enjoyed the class today. Tomorrow by 9 p.m. we'll continue. Physics will continue from there with these two auto assignments. I want to see your answer tomorrow. All right. Wish you all good night. Good night, good night, good night, good night. Good night. Have a lovely night. You can also wish us good night too before you go. Yes, thank you very much. Thank you very much. See you tomorrow by 9 p.m. See you tomorrow by 9 p.m. Yes, yes, yes. Good night, everyone. Sleep well, sleep well, sleep well. See you tomorrow. See you tomorrow. Someone says, sir, please redictate the last question. Redictate the last question. Okay. A particle of mass 0.4 kg. A particle of mass 0.4 kg is subjected to two forces. F1 equals to 2I minus 4J. F1 equals to 2I minus 4J. And F2 equals to minus 2.6I. And F2 equals to minus 2.6I plus 5J. If the particle starts from rest at the origin, find its position and velocity at t equals 1.6 seconds. At t equals 1.6 seconds. Yes. All right. Good night. Thank you very much, everybody. Good night. Thank you very much. Yes. See you all tomorrow. See you all tomorrow. See you all tomorrow. I'm leaving the board so that anybody that is still writing can still write. Someone said even the first question, please. The first question is still on the board, but let me dictate it again. A body of mass 6 kg. The first question, a body of mass 6 kg. Moving with a speed of 20 meters per second. A body of mass 6 kg. Moving with a speed of 20 meters per second. Is suddenly hit by another body. Moving in the same direction. Thereby changing the speed of the former body to 50 meters per second. To 50 meters per second. Yeah, someone said subscribe. Thank you. Yes, if you have not subscribed to our channel, someone said great teaching. Good night, sir. Well done. If you have not subscribed to our channel, hit the subscribe button. You're not paid. It's not. Some people when they hear subscribe, I think it's money. It's not money. It's free. Just hit the subscribe button so that if we go live in any of our classes, you'll be aware. Yes. Okay. Well, so what's this impulse received by the first body? What's the impulse received by the first body? Praise Evan said good night, sir. Thank you. Yes, Lord girl forever says, sir, thank you for today. See you tomorrow. Good. Yes. Good night, sir. It's Kalina forever. Yes, good night. Uzoma said, nice class, but I joined late. Good night. Okay, join us earlier tomorrow, eh? Uzoma said, I joined late. Don't worry, the video will be posted on our channel. You can watch the ones you missed. You can still watch the one you missed. Thank you so much, sir. Yes, Favor said, good night. Yes. Favor Godwin. Yes, 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 yes. I'm just leaving it in case to those that are still writing the questions. Some people's network might be bad. I'll soon cut it off now. I'll soon cut it off. Yes. Good night. Yes. Good luck. Say good night and sweet dreams. Yes. And Maxi said, will it still be on YouTube or Telegram tomorrow? Tomorrow will be YouTube. Tomorrow will be YouTube. It's like YouTube. There was less complaint of network is blurry. Adizwa Clinton. Good night. Yes. Yes. Good night, brother. Yes. 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 Okay. Good night, everyone. See you tomorrow 9 p.m. Yes.